Yes.
Why is video private?
It's still
Why would I
private.
make the video public?
It's still private.
It's not private. Okay, say it's not private again. Okay, somebody's watching already.
Is it the same link?
Alright, please confirm if you are seeing this video. Just type on the comment section so that we can have feedbacks. If you are watching this video via your YouTube, we are starting with Physics 102 Electrostatics. Okay, so let's hear from you. Are you seeing the video? Can you see the board? I want to get comments from you before I proceed, please. Before I proceed, yeah. Give me your comments, please. If you can see the video, let's just say yes. If you can't see the video, say no. Please say yes or say no if you can't see the video. If you can't see the video, say no. If you can see the video, say yes. If everything is clear, let us know, please. All right. Okay, so welcome to today's class on Physics 102. I remain Favor, and this is Intel tutorial. So we are not going live with our YouTube channel today, but from next class, I'll be uploading videos for each particular material that we do, okay, on the channel. All right, so we're going to be starting with the beginning, the basics of physics when it relates with electrostatics, and trying to go further on some complexity of the course. Okay, we just finished Mass 102 and we stopped somewhere there. Continue from that very soon. Okay, a lot of people have asked me, they said, okay, Uncle Favor, what is the issue with physics? Why is it this complex? Well, the truth is this, please, if you can't see the board, let us know. If you can see, indicate on the comment section. Some people say everything is clear, some people are saying it's really blurry. Please let us know if you can't see the board so that we make it clear for you to see. Alright, please just type in I can see the board or I can't see the board so that we can know what to do from that end. Alright, so is Ali seeing update it?
No, someone says clear.
It's clear.
Everything is clear. It's not private again. It is clear.
Where's my
So when you chatting.
All right, so thank you for waiting, and we're about to start. Starting with electricity, electrostatic force, and everything that relates with that. Okay, so we're starting with electric charge, and this word actually you call electrostatics is a compound word. Okay, it's actually a compound word that was gotten from two main original words. Okay, electricity and statics. Electro and statics. If you want to write the definition of electrostatics, although it's not in our course material or your course material, but I would like to tell you what it means so that you have a general knowledge of what we're talking about. Alright? So if you can't see, please let me know. Alright? So if you can't see the board, let me know so that we can work on that. Okay? So electrostatics, okay, is the study of electric force and fields. Okay? And we want to learn the study of electric force and the fields where electricity actually has its place there. Okay, so if someone wants to define this for us, all right, it can tell us that, okay, there is a force, okay, that makes electric charge or current, okay, makes it able to move at the same time keep it at a restricted position. All right, so that is simply the idea of everything here. So if someone wants to define this particular term, you can say that this is simply the magnitude of force that keeps an electric charge at a particular position. Okay, so what we're going to be looking at here is charges. We're talking about currents, talking about the forces, the amount of force that actually makes these quantities or keeps them at that particular point. Okay, statics. If you want to know what this word statics means, it means you are at a point, you're not moving, you are just there. All right, then electro is talking about electric charge, electric current. But I would like to tell you the difference between the both of them so that you don't compare or say, okay, electric charge, same thing, electric current. They are not the same actually. Yeah, there's a very big difference between electric charge and electric current. Okay, so that you don't get two of them as the same. Maybe when you understand the difference between the two, you can put all right. Sorry about that. I think some of us were not seeing the board, so we had to adjust the resources we are using, the devices and everything, just to make it clearer for us to see. Okay, so a lot has been said. I did not even know you were not hearing me. I was just talking and talking as well. Okay, so can you still hear me now, or you can't hear me? If you can see the board, just let me know. All right. Coulomb's law, yeah. So the study of electrostatics deals with the study of electric charge. Okay, learning how electric charge flows between two different bodies. Okay, because in nature there exists charges. There's a difference between current and charge, as I was saying earlier. I said that a current is actually the flow of charges. Okay, there is a current, an electric current, but there's an electric charge. The charge itself is the positive ones and the negative ones, those little ones. Then when these charges come together, they form one flow of what? Of current. Okay, so you say that since you are studying that, you are trying to study the distance or the flow of electric charges, okay, from one body to what? To another body. So one of the scientists that talked a lot about that, all right, was the man called Sir Charles Augustine de Coulomb. He explained a lot about that. But before he did that, a man called Thales of Miletus was at his farmland, and he's trying to study the properties that some materials actually possess that makes them able to attract other materials to themselves. Okay, so they try to study this material and find out that most of them actually contain some properties. For instance, your physics textbook, I think some new physics textbooks or other materials will tell you that if you take a material and rub on your head, let's say a biro material, you put it on your hair and rub it on itself, that after some time when you use that material to rub on a silk paper or any paper, you find out that there is a little force of attraction between the both of them. Okay, so that force of attraction that attracts those materials together because of their different nature is what you call electrostatic force. Okay, so we are going to be studying this electrostatic force. We are going to be learning how they attract materials together, okay, and the rest of them. All right, so that is just what we're going to be doing here. When you bring a silky material and bring a foam material, just bring them together, okay, because they are different. Okay, because of the fact that they are different. When you rub, for instance, you bring an ebonite rod. I think that was what they used on the material themselves, on the coarse material. Bring an ebonite rod, you rub it on a silky material, rub it on a silk. It gains a charge after you've rubbed it. Then you bring another rod again and rub it on a foam material, a material containing 4 FUR. Alright, you find out that there is another charge that one brings or has its own. So when you bring 2 ebonite rods that has been rubbed on the silk together, you find out that there is nothing attracting them. They are just there. Okay, nothing can push them to bring them together. Okay, that ability for them to just be there and nothing is bringing them together is what we call repulsion. They repel, they don't come together. But when you bring 2 different charges, one from the silk and the other one from the 4, you find out that there's an attraction between this material. Okay, on the coarse material, what was used there was amber. All right, and a lot of stories exist where you refer to amber in physics. Okay, I will not want to go straight into that, but there is a lot of stories there. Yes, but when you bring amber and silky or foam material like that and bring them together, you find out there is an attraction between these materials. So that force of attraction that exists between 2 opposite charges is what you refer to as what? Electrostatic force. Okay, and in electrostatic force we are studying the amount of force that makes it able for 2 charges to do what? To attract themselves. Okay, and we're trying to study the amount of force that makes it able for different bodies too to attract themselves depending on the kind of charge that they do what they have. All right, so doing that we are going to be considering the man's discovery, whose name was Sir Augustine de Coulomb. He talked a lot about charges, okay, especially the opposite ones, and he gave a law that we all know. We call it the law of electrostatics. Okay, some people call it the law of electrostatic induction. Well, the basic thing is that it's about electric charges. All right, so he called it that law. He stated that the law states that when you have 2 charges, whether they are opposites or like, that is the same charges, that there is a very high tendency that when they are opposites, that there will be an attraction. Okay, and when they are the same charges, there will be a repulsion. So he stated in his story that like charges repel while unlike charges do what? Attract. Okay, so when you have a charge, a positive and negative charge, and you bring these bodies together, because this is positive and this is negative, they must do what? Attract. They must attract themselves. They will come together. If you have a boy and a girl, they get married because they're opposite and negative, opposite charges to themselves. Okay, if you have a poor man and a rich man, well, in that case, when you bring a rich man at one side, bring a poor man to sit with him, there should be an attraction. But you know, some guys are very funny. So just basically from the angle or perspective of charges, that when you have unlike charges, there's an attraction. But when they are of the same charges, maybe plus and plus or minus and minus, there's always a what? A repulsion. And because of that particular point, your coarse material explained the possibility of thunderstorms, that in the sky there's an existence of positive and negative charges when it rains. Okay, now when these charges come in contact with themselves, there's what we call lightning. Okay, that when a charge actually comes in contact with a negative one, when a positive charge comes in a negative one, there is what we call a force of attraction that brings them together. And because of this attraction, the resultant explanation to what you call lightning. Okay, that light sparks out of that particular point to indicate that okay, something has happened here. All right, although we are not negating the fact that water, when it's impure, actually contributes to this particular charge current. All right, so that is just what happens there. I don't want to really go straight into that because there's a lot of things to say. Okay, I don't want to stress you with those big stuff. All right, I just want to go straight to what Coulombs has to say when it relates with this. Is it? All right, so let's go straight to what Mr. Coulomb said, and let's talk about the bodies that are charged. Okay, so when Mr. Coulomb or Sir Augustine de Coulomb was talking about charges, one of the things he said is that for there to be bodies, more like things, okay, that contains these charges, that there are three most important things we should check. That when we check these things, we can now discover and bring out probably a statement that should explain what happens between these bodies. Okay, so there are three most important things you want to check. Number one, if you have two bodies, okay, that contain charges, number one, you should study the distance between the two charges. Okay, so if you have charge 1 here and charge 2, you should check the distance that makes them apart. Then number 2, you study the magnitude. Another word for magnitude in physics is called size. The magnitude bit of these charges, the positive one, how big is it? The negative one, how big is it? We study the magnitude of the charges. Alright? Then you should also study the last one, the nature, okay, of these particular bodies or space where those particular charge is. Okay, you study the material that has that particular charges. Okay, you study the bodies or the materials containing that charges. So these three factors are what Mr. Coulombs put into consideration before he derived the law he called Coulomb's law. Okay, so like I said, the first one he said was that like charges repel while unlike charges do what? Attract. Okay, but the second one was where he brought out what you call electrostatics from. He said, okay, that if you have body a body A and a body B, he said that for me to get the amount or the magnitude of the electric force that makes them able to attract themselves, that means for me to get the force of attraction between these two bodies, okay, if they are positively charged, or sorry, oppositely charged, or for me to get the force of repulsion between the two if they are like charges, okay, for me to get that amount of force, that the force itself is actually directly proportional to the quantity of these two charges. Okay, it's proportional to the what? The quantity of the charges. So I can say that, okay, let me write it clearly for you to see. The force, or let's say the electric force, the electrostatic force, sorry, is directly proportional to
Orientator is locked. Rotate device back.
Just put it straight. Hold it straight. It will not stress you. It will not stress you. So we're going straight to look at the Coulomb's law. It states that the force of attraction between two charged bodies is directly proportional to the quantity of their charges, or the magnitude of the charges, and inversely proportional to their distance apart. Okay, what this means is that for there to be two quantities, that there will be a force of attraction between them, or a force of repulsion, that is the electrostatic force. Okay, so because the bodies are charged, I told you before that the bodies can contain positive and negative, positive and positive, or positive and positive, like that. Okay, but as far as there are charged bodies, that for those charged bodies to exist, that there is a distance at which they exist apart from each other. Let's say there is a body A and a body B. The distance is known. Okay? Then since I know this distance, that my force of attraction that makes this thing able to attract themselves is proportional to the quantity of the charge that each of the body has, and inversely proportional to their distance apart, to the square of their distance apart. Okay? Proportional to the square of their distance what? Apart. Alright, so let's go straight to mathematically express this law to see what it really looks when we start solving questions with it. Okay, so that is Coulomb's second law. Okay, but just in case you are asked in your material, it's actually one of the most important laws when it comes to Coulomb. Alright, so we can say that F is directly proportional to what? The quantity of the charges between these two bodies. Okay, that means the body has a quantity of charge A, which is Q1, and then it has charge B, which is QB, and then the force of attraction is proportional to what? Q1 and what? Q2. Okay, then according to the same thing, it says that it is inversely, that is inverse proportion over the distance, the square of their distance what? Apart. Okay, so we are saying that Q1 is quantity of charge 1 Q2 is quantity of charge 2, and R square is the distance apart. Okay, it is proportional to the direct proportional to the quantity of the charges, then inversely proportional to the square of their distance what? Apart. So we need to say a lot about this, but from this point, if you have a question on this, please put that straight on the comment section. All right. This thing here, it's clear. It's clear now. It's clear. So we have that F is directly proportional to Q1 and Q2, then inversely proportional to what? R squared. Okay, so mathematically, you know, in mathematics, I want to remove this sign of proportionality from here. But for me to remove it, I must introduce a constant which we usually call K. Okay, so straight from that point, I can say that F is equal to K times Q1 Q2 over R squared. Alright, so this particular statement now will lead me to tell something about the electrostatic force. So I'm going to say F is equal to K Q1 Q2 over what? Over R squared. So please take note of this formula as you will need it, okay, when you are solving for the electrostatic force between two charges by knowing their distance apart. All right, so one of the things I want to tell you is that when you're solving questions that involve this, most times the electrostatic force between them are always positive, even though the charges are different charges. Okay, for instance, if you are talking about charges that are attracting themselves, of course you know that one is positive and the other one is negative, but at the end your answer would have a positive answer. Just work on this. Now the unit of this particular force is still your basic newtons. It's still your basic newtons, okay, for force. All right, so let's see how we can go from this point to solve further. Okay, so take note of the fact that K is your constant, Q1 is your first charge or quantity of charge, Q2 is the quantity of your second charge, and R square is the square of the distance from one charge to the other what? To the other charge. All right, so let's go straight to work on what is this K value? Where is this K? Well, what will I use this K for? Okay, you need to understand what this thing is so that you don't have issues later with it. All right, so I hope you got this straight, that the electrostatic force is directly proportional to the quantity of the product of the charges, okay, and inversely proportional to the square of their distance apart. Okay, then from this point remove the sign and place with what? K after putting your equal to sign. So it becomes K Q1 Q2 over what? R squared. Okay, so from that point, that is simply how we got to this point. So if you are taking note of anything you are writing there, please take note of this. It is very, very important. So from here now, let's call this equation 1 and go forward. All right.
My data save don't finish.
All right. I'll be ending the class here. I promise to stop the class really is 2 p.m. We need to end the class as soon as possible, as I'll be having other classes from now. So, but let me just run through this for you. Okay, because of the network glitches, I'll record the different video and upload later for us so that we can watch it at our own pace. Okay, this is just to show you, an introduction to the courses and how we'll be taking it via board explanations. Okay, so from this point, this is the electrostatic force, and it's equal to KQ1 Q2 over R squared, like we initially said. But K itself is a constant that is actually equal to 1 over 4 pi epsilon naught. Okay, I know you've never heard of what you call epsilon naught. Okay, but I'll be explaining that on a different video. Okay, I'll tell you how epsilon naught is very important for us to calculate the electrostatic force. I'll tell you what permittivity has to do with this particular force. Okay, permittivity of the material or free space. I'll tell you what it has to do with this particular force. Okay, I'll tell you why the constant is 9 times 10 exponential 6. But for this class, I'm going to be ending it here. So I hope you got value from what I said. We stated Coulomb's law. We told us how we brought about the first equation of F is equal to KQ1 Q2 over R squared. Then we're able to explain the stuff involving how those charges attract and repel, as the case might be. Okay, so I'll see you in the next class for Physics 102, where we'll be solving complex questions and deriving other formulas that will help us to understand electrostatic forces. All right, so once we're done with that, we can go to electric field, and from there talk about the relationship between electric field and gravitational field. Then we look at how it affects Gauss's law. I know some people are already asking, what is Gauss's law? Okay, we'll learn what it is, we'll learn how it affects the area of field space and stuff like that. So physics is not difficult. It only requires your time, your condition of understanding you want to learn. So please, I want to see us in the next class. Although we won't have a live class again till next weekend, but we are going to have video recordings that will be sent to us for us to watch at our own pace. All right, so see you guys next time, and God bless you.
Now it's clear. Everybody don't go rest.